Here we go. 6.3. We're still talking about parallelograms. But this stuff is all how you know something is a parallelogram. Okay, so if you're given a picture, I'm going to give you 5 different ways that you can say, yes, I know that is a parallelogram. Okay, so they all start with this statement. A quadrilateral is a parallelogram if, okay? And really, if we were going to do the conditional statement, we would say if number 1, then it's a quadrilateral, right? If number 2, then it's a quadrilateral. But so that we could just shorten things up a bit, we kind of flip-flopped it. So if both pairs of opposite sides are congruent, then the figure is a parallelogram. So in other words, if you got a picture that looked like this, where these are marked congruent and these are marked congruent, but they don't tell you that you have parallel lines. Okay, this is all they give you from the picture. You can say right now that is a parallelogram. Okay, they don't have to tell you the lines are parallel to know it's a parallelogram. So that's the first one. A quadrilateral is a parallelogram if both pairs of opposite sides are congruent. The second one, a quadrilateral is a parallelogram if an angle is supplementary to both of its consecutive angles. So in this one, you only need to know 3 angles. Say this one is 120 degrees. This one is 60 degrees. And this one is 60 degrees. So if you have an angle and both of its consecutive, so the 60 going up and the 60 going to the right, if both are supplementary to that angle, then we know it's a parallelogram. Why do you suppose we don't need all 4? Why do we only need those 3? Not third angle theorem. I know what you're saying with that, but it's not third angle theorem. Essentially, what's happening is this is a 4-sided figure, right? It's a quadrilateral. What does every quadrilateral add up to? 360. So if these 3 that we have add up to something, that 4th one is always going to match up with this one. So that's why you don't need all 4. You can do it if you just have 3. But we know right now with this picture that that is a parallelogram. Okay. Third one, we know something is a parallelogram, a figure is a parallelogram if both pairs of opposite angles are congruent. So if you got a picture that looked like this, where I tell you this angle congruent to that angle, this angle congruent to that angle, as long as we know that information, either with numbers, maybe they give you 120, 120, 60, and 60, okay? That's a parallelogram, or they just mark them congruent. You don't even need to know the values. We still know that's a parallelogram, okay? Number 4, if the diagonals bisect each other. So if we have this setup where these are congruent and those are congruent, even though they didn't tell us the sides are parallel, we know they are parallel, okay? We know that's a parallelogram if we have those markings. Okay, so those ones so far, you've kind of seen the converse of that already, right? So this is kind of the converse of what we did in 6.2. This number 5 is the only one that you haven't really seen yet. And that one says one pair of opposite sides is both parallel and congruent, just one pair. So you're not going to know anything about the other 2 sides, but you're going to know 2 things about one set of sides. So something like this, if we have a parallelogram, let's say the top and bottom are parallel and congruent. If that happens, then we know the figure is a parallelogram. Okay, so every one of these is markings so that we know we have a parallelogram. Any questions on those 5? Okay, so you should be able to look at a picture after today and say, yep, that's a parallelogram. No, that is not, or we don't have enough information to know in the homework for today. So, example 1 here. It says, for what value of x must RSTU be a parallelogram? What can we do with this given information? Yeah.
Set sides equal to each other.
Right. We know opposite sides have to be congruent, right? So if I set opposite sides equal, it's going to be 4y minus 3 equals 2y plus 5, and 5y equals x plus 8, okay? Well, the question's asking for what value of x. So we want to solve for x, but we have an x and a y in our right equation. So we're first going to solve for y, then substitute the y to solve for x, okay? So start with the left equation there. Take away the 2y. You get 2y, add the 3, you get 8. So if 2y equals 8, then divide by 2, and we get y equals 4. Okay, then once you know what y is, you can take it and plug it in up here. So it's going to be 5 times 4, equals x plus 8. So 20 equals x plus 8. And then you're just going to take away that 8. So x would be 12. So as long as x is 12, then that is a parallelogram. Okay? Questions on that? All right. Moving on then. Example 2 is 4 different examples where you're just telling me, can you prove that this is a parallelogram? So based on what you're given from me in the information here, can you tell me, yes, that is a parallelogram? If so, why? And if not, why not? So look at A there. I tell you DB equals 2 times DE. And I tell you this is 14 and this is 14. Do you know that that's a parallelogram?
Yeah.
Why?
Because.
Diagonals bisect. Who said that?
Oh, I did.
Oh, I swore it was coming from this row. So you doubled this one, meaning these are congruent, right? The markings 14 and 14 tell us these are congruent. So because the diagonals bisect, it is a parallelogram. Okay. All right, look at B. Is that a parallelogram? Why? The angles that are consecutive are supplementary. So this would be yes also. One thing to be careful for on this, I feel like people see this and they just assume that these two numbers add up to 180 because you see the 3 angles, and that's what I gave you in the example, right, was the 3 angles. Just make sure you're actually calculating that. Like, do those two add up to 180? 131 and 49 does add up to 180. So we would say, yes, this is a parallelogram because 131 is supplementary to both consecutive angles. Okay. All right, I would say C is probably the toughest one to figure out here. Do you think that is a parallelogram?
No.
Why not?
Because we need to know the third angle. Oh, wait a second. Oh, wait, yeah. No.
It's one opinion. Why? Okay, that's true if it's a parallelogram, but we're trying to determine, is it a parallelogram? Jared? Why?
Because
Why are top and bottom parallel? They're not parallel because of the 5s. Yeah.
They're parallel because 50 plus 130 equals 180 degrees.
Right. Okay, so here's the thing. 50 and 130 are same side interior angles. And we learned in chapter 3 that if same side interiors are supplementary, then what? Lines are parallel. Okay? So because these two are supplementary, we can say these are parallel. So now we have a pair of sides that is parallel and congruent. Therefore, that is a parallelogram. Because one pair of sides is parallel and congruent. Okay? All right, how about D? Is that a parallelogram?
No.
Why not? Right. It's not opposite sides that are congruent here. It's consecutive sides that are congruent. This is actually called the kite. We'll learn about those a little bit later. But we would say no, because it's not opposite sides congruent. Okay. Questions on that? All right. Last thing then. Example 3 here, it says a table tray can be lifted up or down on hinges as shown. Have you guys ever seen one of those? It's like a table that you can lay flat, but then it hinges up and you can make it like sit in front of you. It's like, they're kind of awesome. Or it's like I've seen it in, we were in Living Spaces the other day, and you just pull it and it pops out towards you. Do any of you have one of those?
No.
They're just awesome. I really like them. But anyway, something like that, okay, it says, will the table always be parallel to the ground if we have this information?
Yeah.
Why?
Because you have opposite sides that are congruent.
Right, so if opposite sides are congruent, it is a parallelogram, right? And no matter where you put that, those sides are going to stay parallel when you hinge it, okay? So your answer would be yes, because opposite sides are congruent. Okay. Any questions on that? All right, last thing, in your book on page 849, there's kind of like a summary pictures of each theorem. We pretty much did that in the notes, is you drew your own pictures, but if you would like better pictures than my pictures, there is just kind of a one-page, here they all are, that you could look at, or just take a screenshot and drop it into your notes if you want. That's fine too. But it's what the notes say, so nothing new, just a better version of my pictures.